Hello, great minds. You're welcome to Organotope Chem Clinic, where chemistry becomes crystal clear. I am Temitope Adeniji. In this episode of General Chemistry, I will walk you through the stoichiometry of reaction. Do chemistry calculations confuse you? Don't worry. I will break stoichiometry into 4 simple steps, and you will never fear it again. What is stoichiometry? Stoichiometry is the study of the quantitative relationship between the reactants and the products in a chemical reaction. It relies on the principle of law of conservation of mass, which states that matter is neither created nor destroyed during chemical reaction. Stoichiometry answers questions like how much reactant is needed or consumed during a chemical reaction, and it also answers questions like how much product is formed in a chemical reaction. In a chemical reaction, the reactant species are found on the left-hand side of the equation, while the product species are found on the right-hand side of the equation. A and B indicate the stoichiometric coefficients of reactants A and B respectively, while C and D represent the stoichiometric coefficients of the products C and D respectively in this chemical reaction. Moving on, can we attempt this question together? The first thing we are expected to do is to balance the chemical equation. We have right here the reaction of magnesium with hydrochloric acid resulting in the formation of magnesium chloride and the displacement of hydrogen molecule or hydrogen gas. Can we consider the first step? We are to balance the chemical equation. So from this equation, we have on the reactant side we have 1 chlorine atom, while on the product side we have 2 chlorine atoms. So we are expected to balance this with 2. Okay, now we have 2 hydrogen atoms on the reactant side, and on the product side we have 2 hydrogen atoms as well. Can we check the magnesium? The magnesium solid on the reactant side right here is 1, and on the product side we have 1 magnesium atom in this compound. Then can we check if the equation is balanced? We have 1 magnesium atom, 2 chlorine atoms right here, 2 chlorine atoms on the product side, 2 hydrogen atoms on the reactant side. We have 2 hydrogen atoms on the product side. So we have a balanced chemical equation. So we move to the next step. Convert given information into mole. Can we check the stoichiometric coefficients of this reactant species? Just like we did right here. The lowercase alphabet that we have in the general equation represent the stoichiometric coefficients. Okay, so the stoichiometric coefficient for magnesium solid right here is 1, and the stoichiometric coefficient for hydrochloric acid is 2. The stoichiometric coefficient for magnesium chloride here is 1, and the stoichiometric coefficient for the hydrogen molecule is 1 as well. Okay, so we have 1 mole of magnesium solid reacts with 2 moles of hydrochloric acid to produce 1 mole of magnesium chloride, and we have displacement of 1 mole of hydrogen molecule or hydrogen gas on the product side. We can take the next step, which is use the mole ratio from the equation. Can we determine the mole ratio? Since we know the stoichiometric coefficients of the reactants and products, we can say we have 1:2 for the reactant. So the reactant is ratio 1:2, while the ratio for the product particles we have 1:1. Okay, for the reactant we have 1:2, and for the product we have 1:1. Can we consider the next step? Convert back to mass. Here we have the molar mass, so we have to determine the molar mass of the reacting species as well as the product particle in this chemical equation. The first species right here is magnesium. What is the atomic mass of magnesium? Yes, that's 24. So we have 24 grams. What is the molecular mass of hydrochloric acid? Hydrogen is 1, then chlorine is 35.5. We have 1 plus 35.5. So we have 36.5 grams for the hydrochloric acid. Then on the product side, we have the magnesium chloride. Magnesium has atomic mass 24 and chlorine has the atomic mass 35.5. But we have 2 atoms of chlorine here. So 35.5 times 2, we have 71. So we have 24 plus 71. Okay? This will result into 95 grams. So the molecular mass of magnesium chloride is 95 grams. Then we have the displacement or the liberation of hydrogen gas on this side. Hydrogen has atomic mass 1 and we have 2 atoms of hydrogen here. So we have 1 times 2, which will give us 2 grams. Make sense? Note that in stoichiometry of reaction, the molar mass is different from the reacting mass. In order to determine the reacting mass, we have to multiply the stoichiometric coefficient of the reacting species right here with the molar mass of individual species in order to determine the reacting mass of the reactant particle. And we do the same for the product particle. We multiply the stoichiometric coefficient of the product species with the molar mass of the individual product particle. Note that the coefficient of magnesium right here is 1. So I have 1 times 24. This will give us 24 grams. So the reacting mass of magnesium is 24. Can we proceed to hydrochloric acid? We have the stoichiometric coefficient as what? 2 times the molar mass of hydrochloric acid, which is 36.5. So this results to 73 grams. Okay? On the product side, we have the stoichiometric coefficient of magnesium chloride as 1 times the molar mass of magnesium, 95. So we have the reacting mass of the magnesium chloride is 95 grams. Okay? Also, for the hydrogen molecule, the stoichiometric coefficient is 1 and we have the molar mass as 2. That means the reacting mass is 2 grams for hydrogen molecule. Make sense? Recall that the number of mole of a substance or amount of substance is measured in mole. So I will introduce mole as the unit of this coefficient right here. Okay. Then the molar mass is the mass contained in every 1 mole of the substance. So it will be given as gram per mole. Therefore, we have this as gram per mole, gram per mole, gram per mole, and we have this as what? Gram per mole. So recall that the number of mole of a substance or amount of substance is measured in mole, while the molar mass is measured in gram per mole. We are going to add the reacting masses for the reacting species. So we have 24 plus 73. Total mass of reactants will be what? 24 plus 73, which will give us 97 grams. So the total mass of the reactant for this chemical equation is 97 grams. Let us confirm for the product particle as well. Total mass of products. Can we look at the reacting masses together? We have magnesium chloride 95 grams and the hydrogen molecule 2 grams. So 95 plus 2. 95 plus 2 will give us 97 grams. Okay? So the total mass of the reactant particle is 97 grams, while the total mass of the product particle is also 97 grams. We can also check if the equation is correct by confirming if the total mass of the reactant is equal to the total mass of the product, which implies that the law of conservation of mass is obeyed. Make sense? Moving on, stoichiometry also allows for the calculation of quantities like the limiting reagents and excess reagents in a chemical reaction. What are limiting reagents? Limiting reagents is the reactant that is completely used up during a chemical reaction, thereby bringing the reaction to a stop, while the excess reagent is left after the reaction has been completed. Can we consider the equation on the board? We have the reaction of hydrogen with excess supply of oxygen to give water molecule. So the hydrogen is the limiting substance or limiting reagent in this reaction, while oxygen is an excess reagent which produces water molecule. Or in other words, we can say that hydrogen bonds in excess supply of oxygen to give water molecule. Make sense? In other words, I can define limiting reagents as the reactant that produces lesser amount of the product, while the excess reagent is regarded as the reactant that produces larger amounts of product. Moving on, can we look at this question together? We have 1.20 gram of calcium combined with 3.5 gram of dilute hydrochloric acid according to the equation right here. Identify the limiting reagents and calculate the mass of excess reagents. We have to identify the limiting reagent, then calculate the mass of excess reagents. So we have the atomic masses right here: calcium 40, chlorine 35.5, and hydrogen 1. Okay? Remember that in stoichiometry of reaction, we have to focus on the reacting mass of the reacting species that we have there. But without the molar mass, we cannot determine the reacting mass. Okay? Can we look at this together? The first reactant here is calcium with the atomic mass 40. Okay? So we have the reacting mass from the stoichiometry of the reaction as, for calcium, 1 times 40 gram, okay, of calcium reacted with the hydrochloric acid here is 2 times the molar mass of hydrochloric acid is 36.5, okay, gram. Now the next thing, from the question, we're given the actual mass of calcium as 1.20 gram. That is the actual mass of calcium that reacted with hydrochloric acid. So that is the next line. We have 1.2 gram of calcium reacts with unknown mass of the hydrochloric acid. Okay, so the next thing is to make y the subject of the equation. We have y equals, which is the mass of hydrochloric acid that we have in this reaction. We have y equals 1.20 times 2 times 36.5 divided by 40. Okay, when you press your calculator, what do you have? From the calculator, we have 87.6 divided by 40. Divided by 40. This will result into 2.19 grams. Whenever you are asked to determine the limiting reagent or excess reagent, you focus on the reactant side of the equation. Right here, the actual mass of calcium is 1.20 gram, while the mass of hydrochloric acid is 2.19 grams. So when we compare 1.20 gram with 2.19 gram, which one is higher? That's right. The mass of hydrochloric acid in this stoichiometry equation is higher than that of calcium. Okay, so the limiting reagent is what? 1.20 gram of calcium. So calcium is the limiting reagent, while the excess reagent is the hydrochloric acid. We have 2.19 gram of hydrochloric acid. So when we compare 1.2 to 2.19 gram, the 2.19 is greater than the 1.2 gram. Therefore, the excess reagent is hydrochloric acid and the limiting reagent is calcium. Make sense? Invariably, I can say that in this reaction, we have 1.20 gram of calcium and 2.19 gram of the hydrochloric acid. So when the 1.2 gram of calcium is completely used up in the reaction tends to stop. Okay, we'll still have hydrochloric acid left in that reaction. If this video lesson made stoichiometry clearer for you, kindly give me a thumbs up and also share this video with your friends and subscribe to Organotope Chem Clinic for more exam-focused chemistry lessons. Always remember that chemistry is not hard when you learn it the right way. Keep practicing and you will get better. Thanks for watching.